Let's next look at the water content of a soil on a volume basis. The graphic that you're now looking at is labeled water content on a volume basis. This is most often referred to as the water ratio of a soil. Now, in your textbook, it's most often talking about the quantity of water held in terms of cubic meters of water per cubic meter of soil. Well, under field conditions, that's all right, but under laboratory conditions, water ratios are oftentimes measured or related to how much water is being held per foot of soil profile. And this formula will allow us to determine that quantity of water. So the water ratio is determined by calculating first the percent of water. That is the gravimetric water content that we've just learned how to calculate. So we're going to take a soil sample, measure the wet weight minus the dry weight over the dry weight to get this percentage of water. We will not take that percentage and convert it to a decimal, but we'll leave it as a whole number percentage. We're going to multiply that percent of water times the bulk density of the soil. You'll recall from a previous unit that bulk density is measured in terms of grams per cubic centimeter of soil. We would want to use the dry weight of the soil divided by the volume that that soil occupies to get the bulk density. Then we're going to take that times 12 inches per foot, because this soil sample is going to represent 1 foot of soil profile. This quantity, when we multiply this out, will be divided by 100 times the density of water. The density of water is 1 gram per cubic centimeter. So this number on the bottom of our equation is always going to be 100 grams per cubic centimeter. But I wanted to show you in the formula where that came from. So 100 grams per cubic centimeter will be divided into the percentage of water times bulk density times 12 inches per foot. When we make this calculation, the grams per cc that are derived from bulk density on the top of the formula will be canceled out by the grams per cc on the bottom of the formula. Percent is a unitless number, so our units on this particular equation, or the answer for water ratio, the units on water ratio, will come out as inches of water per foot of soil profile. So we'll be utilizing a standard soil probe with a 1 foot core sample that takes a 1 foot core sample. The volume of that soil will be known based on the volume of that cylinder, and it will represent each foot of the soil profile. We would most often use water ratio if we were wanting to look at how much water is being held in inches of water per foot of profile. So we might want to do a profile analysis for dryland wheat as an example. We would probably want to know the total and available water, and available, of course, is going to be based upon the crop that's growing in that soil, but total and available water per foot of profile throughout the effective rooting depth of that particular crop. Water ratio then will be expressed as inches of water per foot of soil profile, utilizing this formula and the technique that I've just described.